Congratulations, you got the job. You're now a developer for the world's #1 backend provider for pizza restaurants called Plant-Based Pizza. And I'm James Eastham. I'm here to help you get onboarded into the code base, learn about how we build and think about software architecture and systems design here at Plant-Based Pizza, and generally help you to get up to speed with the patterns and practices that it takes to build a modern distributed system. One of the things we value more than anything here at Plant-Based Pizza is simplicity. And Werner Vogels talked about this in his 2024 AWS reInvent keynote, how unnecessary complexity is one of the killers of modern software systems. Simplicity, evolvability, portability. Think of those as the three pillars, the three overarching guardrails we use to think about software design here at Plant-Based Pizza. Complexity is a tricky beast though, right? There's lots of different types of complexity you will hit against as you build a modern software system. They're primarily categorized into two different types of complexity. The first being essential complexity. Essential complexity is the complexity that's fundamental to the problem that you're trying to solve. For Plant-Based Pizza, that's the ability to take orders, to deliver orders, to create pizzas, to generally just make sure when somebody wants a pizza, they get the pizza that they want. Accidental complexity though, that's the other type of complexity. That's the complexity that comes from the decisions that you choose to make as a developer or an architect. Build a monolith or build with microservices. Build with Kubernetes or serverless. Choose to use DynamoDB versus Postgres. All of these things have their own types of complexity. And a fundamental goal of modern software systems should be to reduce this accidental complexity as much as possible. Your users do not care about how much accidental complexity you have in your system. They care about how well you solve the essential complexity. I know what you're thinking though. What does that mean for me as a developer? In this first session together, you're going to take away some of the core building blocks that we use to think about software at Plant-Based Pizza. And frankly, these building blocks are building blocks that make up any modern software system, any modern distributed system. But as well as understanding these building blocks, you also need to understand how you can use these building blocks in as simple a way as possible. At the core of all software, there is some kind of compute, some kind of application code that's executing your business logic, that's solving that essential complexity for your users. This business logic will be invoked primarily in two different ways. The first, with some kind of user accessing your system, calling your system directly and waiting for some kind of response. Note that this user may not necessarily be a person, it may be another software system. That's one way that your business logic is going to be invoked, some kind of synchronous request where the user is expecting some kind of response. The second primary way where your code is going to be invoked is some kind of asynchronous process. Maybe that's messages building up in a queue, maybe that's events being published to an event bus. You've got these asynchronous processes that there isn't anybody waiting for. You've got synchronous processes, you've got asynchronous processes. We've got web workloads and backend workloads, two primary ways of running compute. You could actually really think of these as two different separate processes. You've got one process handling your user-facing workloads, and you've got one type of application handling your asynchronous tasks. Both of these things are probably going to need some kind of persistence, some kind of way to store state. Keeping this middle layer, your application layer, as stateless as possible is what will then allow you to scale your system out to deal with load, which means you're going to need some kind of state store. And this here makes up the core of pretty much every software system you will ever come across. Maybe all software systems don't have all three of these pieces. Maybe some of your systems just have a backend process. Maybe some systems just have a web process and a database. These building blocks, a synchronous request response style of compute, asynchronous backend style of compute, and some kind of persistence layer. When you're thinking about architecting and designing modern software systems, these are typically the core components that you're going to need. Now, the real challenge for you becomes how do you run these core components in a way that minimizes the accidental complexity as much as possible. Remember, you want to move fast and you want to solve the problem for your users in as simple a way as possible. How exactly can you do that? Regardless what your thoughts are on Kubernetes, on serverless, on running things on a virtual machine, all software decisions you make should be made somewhere along this spectrum. The way you choose to run your application affects how much accidental complexity you adopt inside your organization. The question you should be asking yourself, how do you run this component of plant-based pizza in a way that is as simple as possible, that reduces the accidental complexity as much as possible? And if you're working on other systems, you can ask that exact same question. How do you run this specific piece of your system in a way that reduces accidental complexity? Let me take you back through the history of plant-based pizza so you can see how these decisions get made as a system evolves over time. And in the beginning, plant-based pizza was a simple monolithic application with a single database. That was it. That was plant-based pizza. It was simple to deploy, simple to reason about, simple to think about. But over time, as more and more developers started contributing to the code base, this got a little bit tricky. People started getting in each other's way. This generally led to a frustrating experience for development teams at Plant-Based Pizza. So whilst technology complexity was low, human complexity, the social complexity, the way people had to communicate with each other to get work done was high. But we stuck with this for a little while. This application was picked up and deployed to Azure Container Apps. We even tried out running the same application on ECS Fargate. We packaged it up as a stateless container and used MongoDB as the database provider. That gave us the flexibility to move this container image around whilst also choosing an extremely flexible data store that allowed us to pivot and change as we started to understand the domain a little bit better. The technology choices in these early days were intentionally portable. This initial version of the system was designed with portability and evolvability in mind. We didn't want to be stuck in one specific technology provider, one specific way of building applications. A simple container image with a simple database, that gave us the best balance of both portability and evolvability. Of course, we grew. Pizzas are incredible. Everybody loves pizzas. So the system started to grow. We started to get more and more users, more and more development teams, more and more developers, all contributing to this same monolithic code base. The technology complexity was still relatively low with the simplicity of the architecture, but the human complexity was starting to go up and up and up because there were more and more people starting to contribute to the code base, which led us to slowly start to break down the system into a more microservices architecture. Each individual team working on their own individual microservice. Microservices grouped around their specific business domain. Because we've been running the monolithic system for so long, we had really well understood and really well defined domains. So this breaking down into specific pieces of business logic was relatively straightforward. And now each individual development team were all contributing to their own code base, all using a specific technology and database provider that suited them. But inside each of these microservices, them same core components still existed. There was some kind of web or user-facing workload, some kind of backend workload, and that repeated for all of the different microservices. And of course, each microservice had its own database. This meant that any user traffic that came into the system was routed to the relevant web workload, and all service-to-service communication used events, which of course ran through the asynchronous processing workloads. This really clear separation between a web workload and a backend workload. Imagine this is the orders service. You've got one service inside that domain dealing with web requests for the orders, and one service inside that domain dealing with any asynchronous processes related to order processing. Teams still prioritized stateless compute though, and that allowed the teams to pick up and deploy these applications really simply using Azure Container Apps. They could pick up and deploy their applications by simply defining the CPU and memory requirements for the application, and Azure handled the rest. You could ship all of these container images without worrying about underlying infrastructure. When we think about simplicity in running systems, this has got to be one of the simplest ways to run an application. Stateless compute packaged as a container image, running in a way that means you don't need to worry about managing infrastructure. Remember, simplicity is one of the core building blocks. Now, we've added a few more building blocks over that time, as well as separating between web workloads and backend workloads, and having some kind of storage layer. We've also found that we needed to add some kind of caching layer to help deal with performance, to help deal with service-to-service communication, and storing temporary copies of data. So we added caches. As we started to adopt a microservices architecture, we wanted to prioritize loosely coupled systems, building an event-driven architecture to reduce that need for service-to-service synchronous communication. So we also adopted some kind of messaging layer to provide that service-to-service communication using asynchronous events. Just publishing events wasn't quite enough though. In some cases, we had really clearly defined business workflows that we wanted to make sure were completed successfully, which led us to build orchestrators to orchestrate specific business workflows. And of course, observability is a core cross-cutting concern across all applications inside a system. This gave us the core building blocks of modern software architecture: web-facing synchronous workloads, back-end more asynchronous workloads, some kind of storage layer, some kind of caching layer, messaging, orchestration, observability. The core building blocks of modern software systems. Now, don't worry, I know it's your first day here as a developer at Plant-Based Pizza, and that sounds like a lot to think about. But over the coming weeks, we're going to dive deeper into these different components of modern software architecture together. And you'll see lots and lots of different examples from inside the Plant-Based Pizza application codebase, both from the historical monolithic codebase, also from the modern event-driven microservices architecture. From web and back-end workloads through to orchestration and choreography, database choices, CI/CD, idempotency, and the outbox pattern. Stay tuned, you're going to learn all about that and more over the coming weeks. But for now, take a breath, grab your notepad and write down what you've learned today, what you've learned about the components of modern software architecture, and I'll see you all next week.